Good morning. Today we start on Chapter 10. Chapter 10 deals with graphs and trees. You should start reading this in your book. Graphs are a very interesting subject. They arise in a lot of applications in network analysis, network flow. You'll encounter them in a class in data structures. A lot of computational problems are based on graphs. Now, conceptually, graphs are actually a very simple issue. They're made up of two things. A graph G is actually comprised of two things, a set of vertices and a set of edges. Okay, so both of these are sets, and let's go ahead and just give a couple of simple examples, and then we can give some definitions. Now, first of all, we have these things called vertices. Okay, and vertices is the plural. The singular is the word vertex. And that is an E over there. There we go. Another word for these would be nodes. And what we would do over here is we, for a particular graph, we might say that V is composed of these four nodes that we're going to give names. And then what happens is we have a set of edges. And the notation I'm going to use is a little bit different than your book, but what I'm going to say here is something like the following. There's an edge going from A to B, and maybe there is an edge going from C to D, and then there is also an edge going from A to C. So it looks like that. So there are two different sets that actually define a graph. We can see it's the vertices and the edges, and very frequently people call this set E. Now we can draw a picture of this, and we come over here and we have a node there that's called A. We have a node over there that's called B, and we'll have a node over here called C, and we'll have a node over here called D. And then let's see, according to our set of edges, there is an edge from A to B, so that would correspond to that. And there is a set going from C to D, and that would correspond to that. And then there is an edge going from A to C. So we would come over here and we would have that. Okay, so what we have over here, this is the picture of the graph. Now, there are actually lots of ways that we can draw this picture, and they're all equivalent. For example, I could come over here and I could say, well, here's A, and I could come over here and say, here's C, and I could come over here and say, here's B, and I'd come over here and I would say, here's D. And again, I have to draw the edges, so I would draw this one here like that, and I would draw one between C and D, and it looks like that, and I would draw one between A and C, and it would look like that. So these two graphs are completely identical, and in fact, we have a special word for that in mathematics. We would say that they're isomorphic. Okay, iso, I believe, comes from the Greek meaning the same. Morph means form. So we're saying that these two graphs are actually identical. Now, there are a couple of definitions we have to give here. First of all, let's come over here and look at this graph here. And we would say that A and B are neighbors, or that they're adjacent. Okay, so we would say over here that they are either adjacent or we could say that they are neighbors. Okay, we would also say that there is a path from A to B. That's very important. Okay, a couple of other definitions that we should give here. We should talk about what are called the neighbors. So for example, if I were to come over here and talk about what are the neighbors of A, and we'll denote that by n of A. Okay, that's equal to the set of all of the vertices that are in fact adjacent. Okay, so we would say over here that A has neighbor B and it also has neighbor C. Like that. In a similar fashion, we would say that the neighbors of C are A and D. We would say that the neighbors of D are C. We would say that the neighbors of B is A. Okay, I hope that's clear. Okay, next, I'd like to consider there are different types of graphs that we'll be talking about in here. So we want to give some quick definitions and examples of what these are. The first distinction that we want to make here is there's what are called directed graphs versus undirected graphs. So there's directed versus undirected. And the distinction here is the following, that in the directed graph situation, you can think of it as like a one-way street. We have specified an arrow that tells us which way the path goes. In the undirected graph, we can assume that the path is bidirectional. You can go either way, so you won't see an arrow on it. Okay, so to give you a couple of just contrasting examples here, let's just consider the following graph. And let's make this a directed graph. So we have an arrow going there, and then we have an arrow going this way, and maybe we have an arrow going this way. Something like that. Let's consider okay, this would be an example. Okay, no arrows. Okay, so for example, we're going to talk later on about the notion of a path and can you get to one point from another. The question is in these graphs, I want to ask the question, is it possible to get from D to A? Now, we come over here in the directed graph and we see that there is an edge that comes into D, but there isn't an edge that goes out. So there actually does not exist any way to get from D to A. But over here, we note that, again, because the edges are bidirectional, I can get to A lots of ways. I can go from D to C to A, and I can also go from D to C to B to A. Now, when we come to specifying these graphs, we have to use a slightly different notation. For example, in this graph over here, when we wanted to say that there was an edge between A and B, we just denoted it, the edge, like this. Okay, we specified it as a set, and you may recall from our discussion of set theory that there is no difference between this set and this set right over here. Okay, so that what we're doing over here in the undirected graph is that when we specify something like that, we're specifying that you can go in either direction. What we're going to do over here to specify that there is actually an orientation or a direction of these edges here is we're going to use an ordered pair. So that if I want to specify that there is an edge from A to B, I'm going to come over here and I'm going to make it an ordered pair. And I'm going to say AB. And then we would also say that there is an edge from B to C. So I'd come over here and I would say B, C. There is an edge from A to C. And then there is also an edge from C to D. And this is now equal to the edges of this graph right over here. Okay, so the important distinction, remember, for a directed graph, we are using ordered pairs to specify the edges, and in an undirected graph, we just use sets.